Hello again, Cubs. Let us try to answer for chapter 9, problem number 94. In problem 92, you examine what happens in different functions when x becomes large. Now you will investigate the patterns of growth of three familiar types of function. How do linear, quadratic, and exponential function grow for different values of x, both small and large? Use your graphing calculator to answer this question with your team by investigating the following functions. So for our first function, we have a linear function, which is f of x is equal to 2x minus 1. Our next function, g of x, is quadratic, which is 2x squared minus 1. And our exponential function, the last, is h of x is equal to 2 raised to x minus 1. Now what we're going to do is to use our graphing calculator. You can use your Desmos graph, or you can follow what I did, manual graphing. So I actually made the earlier video about this. That's why there's an answer here. But it was too long, and YouTube doesn't want it to be uploaded because it was more than 20 minutes. So what I'm going to do is just to show you how I answered this earlier. So using our calculator, you just substitute the value of -2, plug in the value of -2 here in x in your calculator like this. So I'll just show you one, and then you can practice doing the rest. So 2 times -2, okay, minus 1 is equal to -5. And then for the next one, you substitute -1.5 in here. Minus 1, you'll get -4. And then -1 in here. Using your calculator, you'll get -3. And so on and so forth. So for g of x, same thing. I plug in -2 in here just to show you the first one. So that's 2 times -2 squared minus 1 is equal to 7. And then another one, just to show you, that's -1.5 squared minus 1 is equal to 3.5. So the next one is 1, and so on and so forth. For h of x, same thing. So you get 2 raised to, so this is your exponent, -2. I usually get the equal sign again first, and then -1. In your calculator, you will get -0.75. Try that again. You have 2 exponent -1.5 equals minus 1 equals. So you have -0.65. And then you plug in -1, -0.5, and so on and so forth. You get this value until here. So that is our table. Now I made it shorter so that I can spend a shorter time in the video, because they do not allow me to have more time in the video. So I cannot upload it in YouTube. So the second thing to do is to graph. You can use your Desmos graph, but to show you, so first you graph -1, okay, or you can just graph this. This is -2 and then 5. So this is my first graph, my first point. And then I'd like to use -1 and then 3. So this, and then 0. We have -1, as you can see, 1, 1 here, and so on and so forth. If I connect all these points, 2, 3, and 3, 5, your line is straight going like this. Okay, so that's our f of x. Okay, the next one, I will use the red one for the g of x. So negative 2 and then 7. So this is my first point. And then negative 1, 1 here. And then 0, negative 1. So 0, negative 1 here. And then here. And then here. I have actually a point here that is negative 0.5 to 0. Negative 5. So this is my graph. If I will connect, oops, let's make that nicer. Turn of the parabola. Okay, and then arrow going up. That is our g of x. For our h of x, we'll have 1, 1, 1, 1 here, another point of intersection here, and we have 0, 0 here. Okay, and then we have negative 1. Okay, negative 1 and negative 0.5 going smaller. Okay, and then we have a 2, we have 3 here, and then at 3 we have 7 here. So as you can see, our graph is going up like that and going up like that. So this is our h of x. Okay, so that is our graph. And for our next answer, okay, for this we will have an increasing. Okay, I would like you to discuss this a little faster, just to write down, because I'm running out of time. So for our f of x, we can write increasing for all x. As you can see in our graph is increasing for all of x. Okay, and we have the pattern of growth. Is adding 2. Now, why do you mean by adding 2? If you check our graph, okay, for f of x, for 1 we have 1, for 2 we have 3. The distance or the difference between 1 and 2 is 1. Here 1 and 3 is 2. 3 and 5 is 2. For each 1 unit of x, there is adding of 2 for f of x. Why? Because our slope is actually 2. So pattern of growth is adding 2. For g of x, okay, we have from the graph less than 0, our parabola is decreasing, going to the right. From left to right, when x is less than 0, our graph is decreasing. So we can write decreasing for x is less than 0, and increasing for x is greater than 0. As you can see in our graph, when our x is greater than 0 to the right, our graph is increasing, going to the right side. Also, our graph is growing and increasing amount. So the graph is growing, or we can say grows by an increasing amount. So what do we mean by that? Okay, as you can see in our table, from 0, it's negative 1, it becomes 1. From 0 to 1, it becomes negative 1 to 1. So the difference here is 2. From 1 to 2, our graph becomes 1 to 7. So there is an increase of 6 from 1 to 7. And from 2 to 3, there is an increase of 7 to 17. That's 10. So from here, that's an increase of 2. From here, an increase of 6. And from here, an increase of, from here, an increase of 10. Again, from negative 1 to 1, there is an increase of 2. From 1 to 7, there is an increase of 6. And from 7 to 17, there is an increase of 10. So, increasing amounts from 2 to 6 to 10 and so on. And then for f of x, we say that the graph is increasing for all of x. As you can see, the green curve, this is our exponential function. The graph is increasing for all x. So we write increasing for all x. Okay. And the pattern of growth is adding of powers of 2. What do you mean by this? Powers of 2. As you can see, from 0 to 1, the difference is 1. From 1 to 3, the difference is 2. From 3 to 7, the difference is 4. So the increasing of power of 2. Here, 1, and then here 2, and then 1 times 1 is 1, and then here 2 times 2 is 4. So the increasing from 1 to 3, that's 2. From 3 to 7, that's 4. So because of 2 times 2. The next one will be increasing of 8. Because 2 times 2 times 2 would be 8. So that's why we have an pattern of the growth is adding of the increasing powers of 2. So I will end my video here. I will answer letters C and F and D on the next video. I only have less than 15 minutes for each video.